Welcome to the Kusto Query Language from Scratch course. In this module, you'll learn like a machine, covering the machine learning operators in KQL. I'm Robert Kane, and I'll be your host for this course. Machine learning has become a critical tool in many companies today, so much so that the Kusto Query Language has functions built right into the language for it. In this module, you'll see how to apply KQL's machine learning functions to do basket analysis on your data. Additionally, you'll see how to apply clustering algorithms as well as looking for difference patterns. For your reference, here is a list of the keywords we'll be covering in this module. Each keyword will be in a clip of its own for easy reference in the future, should you wish to return and refresh yourself on a specific operator. In machine learning, one of the most frequent uses is to do frequency analysis on combinations of data. It's often referred to as basket analysis because many companies use it to do analysis of people's shopping carts and determine which combination of items are purchased together so that they can use that in recommendation engines. Under the hood, the basket command in KQL uses the a priori algorithm. Put simply, the a priori looks for the most common occurrences for each individual column and then looks for the combination. So in this example, it's going to go through and it's going to look for the most frequent occurrences of computer. Then it's going to look for the object names that occur the most frequently, and then the counter name and instance names that occur the most frequently. Once it has determined those, it can then look for the combinations of those that occur the most frequently and return that information back. And here is our output. Over on the right, we have our computer object name, counter name, and instance name, but we also have some information to the left. Primary interest to us is the count and percent columns. So if we look at this, we'll see that where there is no computer name, no counter name, no instance name, but we have an object called process, those are responsible for 715 million rows in our input data set, or 70% of the data. The next row tells us that the combination of empty computer, empty instance name, with an object name of process and a counter name of percent processor time, is responsible for 14% of the data, or 146 million rows. The basket command in KQL does have a parameter we can pass in. This is the threshold. The threshold is what determines the minimum frequency a combination must occur in order to be considered for inclusion. Now within KQL, we use a ratio between 0 and 1, the default being 0.05. So let me run this query first, passing in a threshold of 0.01. What 0.01 is going to do is it's going to make it very flexible, and we will wind up with more rows being included. Now this query takes a few minutes to run, so let me pause this and I'll catch you on the other side. And we're back. That took a little over 2 minutes to run, and as you can see on the right, we brought back 127 rows. This is because the low number really opened it up and made the threshold for inclusion very low. In other words, it was a lot easier for a data point to get included. Now let's flip this on its head. Let's come over here and change our threshold to a very high number. We'll use 0.09. I'll then rerun the query, and what we've done now is we've made it much tougher for data to be included in our output. There we go. This ran very quickly, just 10 seconds, and it returned 7 records. So as you can see, it was a lot tougher for a combination to get included. We were very strict about what qualified for inclusion within our basket analysis. I will mention that there are a few other parameters for basket. However, they're not very frequently used. So if you feel like this basic basket call you've seen here isn't quite meeting your needs, Take a look at the online help where you can get a little more information about the other parameters.